Algebra 2, Unit 4, Section 4, System of Equations with three variables, points given. So really what this question is showing us here is they're giving us 3 points that are on a parabola, and we want to get the equation of a parabola from that. And we're going to end up creating a system of equations that we are familiar with from the previous chapter. But we have to be very familiar with the standard form of a quadratic equation to be able to do this. So the standard form of a quadratic you should be familiar with is y equals ax squared plus bx plus c. And you've seen these a, b, and c's in a couple of things. You've seen it in the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. You've seen it in the axis of symmetry, x equals negative b over 2a, and all that, stuff like that. Most recently, we've been doing parabolas using the focus directrix formulas of, let me just go back a couple of pages to show you the 4p parentheses y minus k equals x minus h squared. This is the vertex form formula for a parabola, that given the distance and vertex, we could get the equation of a parabola. But ultimately, in these problems, we still worked out to get the parabola into an ax squared plus bx plus c form. And so that's what we're still trying to do here. We're trying to get the equation of a parabola. And what we're given is 3 points on it. We're not given a focus directrix or anything like that. And we're actually not going to be using focus directrix in this. We're going to be using systems. So what we have here are x and y values. These are coordinates. And what we can do is we can plug these in for these x and y's up here. And what we're not going to have is we're not going to have things for a, b, and c. They're going to stay a, b, and c. But let's see what happens when we substitute these numbers in for x and y. And so for the first one, 1, 6, and I'm going to write this over here. 1, 6 substituted in gives us 6 equals, because that's y equals, it's the y value equals, a times x squared. Now a times 1 is 1 squared, so that's just 1a, or just a, plus b times x is b times 1, so that's just b, plus c is just plus c. So we get 6 equals a plus b plus c. Sorry, my 6's look like b's, but try to make them a little bit different. But this is a c, 6. This is a b. That's a c. Next point, let's try 320. And so first off, we're going to plug in the y value, and that's going to be 20 equals, now ax squared will be 9a, because that's plugging a 3 into x squared, and 3 squared is 9. And I could write a9, but 9a is typically how we write when a number times a variable, the coefficient goes first. And then b times x, with x being 3, is going to be, instead of 3b, it's going to be 3b, actually, sorry. I was going to say instead of b3, again, I just kind of put the number in front instead of behind. But b times 3 is 3b, and plus c. And the third one, I'll use red, negative 2, 15. Plug that in. It gives me 15 equals for y equals. And now a negative 2 plugged in for x squared. Negative 2 squared is positive 4. Never forget that a negative squares to positive. It's a very common mistake we see in high school. A lot of students want to make it negative 4a, but it's just positive 4a. Now bx is b times negative 2. That is going to be negative 2b, and plus c. And what we've done here is we've created a 3-equation, 3-variable system, just like we saw in the last chapter. And we're gonna figure out a way to combine these to get something, figure out a way to combine these, cancel out a variable. And so we're gonna do exactly what we did in the previous unit for solving 3-variable systems. What's nice about this is these equations, because there's no x or y attached to c, they always have plus c. So it's actually really easy to combine these. You basically just have to negate one of them, so it ends up with a negative c, and combine it to the other two. So the c's are very easy to cancel out here. That's what I'm going to choose to do. I'm going to choose to negate this middle equation. So let me multiply this by negative 1. Make it negative 20 equals negative 9a minus 3b minus c. And I'll pair it with my top equation, 6 equals a plus b plus c. And let's see what that comes out to be when I add these together. Negative 20 and 6 is negative 14. Negative 9a is negative 8a. Negative 3b and b is negative 2b, and the c's cancel out. All right, I'm also going to take that negative 20 equals negative 9a minus 3b minus c, this middle equation times negative 1, and pair it with the original bottom equation, 15 equals 4a minus 2b plus c. Remember, don't be afraid to pause. I do kind of write fast. Instead of writing that over there, I'm going to put the answer over here. This way they're next to each other. So these will combine. Negative 20 and 15 combines to be negative 5. Negative 9a, 4a is negative 5a. And negative 3b, negative 2b is negative 5b. All right, so we've successfully taken 3 equations with 3 variables and combined it down to be 2 equations with 2 variables. And now I'm working just here. And I want to figure out a way to cancel out, this type of stuff in here. Looking at the a's and the b's, there's nothing simple I could do here. I'm going to have to change both of them. Looking at the b's, this will probably be the easiest. I figure out a way to make, this into if I multiply it by a 5, then that will become a negative 10. And if I multiply this by negative 2, it'll become a positive 10. Because remember, I need opposite signs like we had here with the c's. Same number opposite signs called additive inverses. So if I multiply the top equation by 5, that is negative 70 equals negative 40a minus 10b. And the bottom is positive 10 equals 10a plus 10b. And the b's have an additive inverse there now. So when I combine these, I get negative 60 equals negative 30a, and so I can simply divide negative 30, so now it's a 1 equation with 1 variable. So we go from 3 equations with 3 variables to 2 equations with 2 variables to 1 equation with 1 variable, and I end up with a equals 2. All right, so that's the hard part. Now I just got to go backwards, and I got to plug back into the 2 equation 2 variables. I can't talk today. And let me do some of that work over here. I'll choose that bottom equation with all the negative 5. So that was negative 5 equals negative 5a, but now I can replace a with 2 minus 5b. So it's negative 5 equals negative 10 minus 5b. Add this 10 over to get positive 5 equals negative 5b. Divide negative 5b equals negative 1. And now that I have these, I can go back to one of my 3 equation 3 variables, and I'll choose the top one. Looks like the easiest. 6 equals a plus b plus c. So 6 equals a, which is 2, plus b, which is minus 1, plus c. That's 6 equals 2 minus 1 is 1, plus c minus 1, 5 equals c. Now I'm not going to write this as a coordinate like last time we would write 2, negative 1, 5, but this isn't, I'm not looking for a coordinate. What are we trying to do here? We're trying to determine the equation of a parabola. Well, now that I have this, I know my parabola is y equals ax squared plus bx plus c. Well, now I can substitute what I have. So this is y equals, a is 2, so 2x squared plus bx is minus 1x. I'll just write minus x, and plus c is plus 5. So I'm plugging my a, b, and c's in for that. So it's really not too bad. It's one at a time. Plug the coordinates in here to get your 3 variables, and then it's something that we've done, in a previous unit. One thing that's nice here is the check is very easy. Type in your final answer. Just move this for a second. 2x squared minus x plus 5, and simply look at the table. And what I want to look at on the table is I want to see if these 3 coordinates that I originally started the problem with are there. Scroll down here, I see 1, 6. Then there's 3, 20. And up to negative 2, 15 is right there. So all 3 points are on this parabola, so that obviously has to be the parabola. So that's it. A little bit of system stuff from the last chapter, but working in some parabola concepts from this chapter. All right, that's it. See ya.